Imagine you're standing at a busy intersection, watching the traffic lights change. Ever wondered how they're programmed to ensure smooth traffic flow? Today, we're diving deep into the technical challenge of programming a traffic light using KOP, or Key Object Programming, and markers. This isn't just about turning lights on and off, it's about orchestrating a symphony of green, yellow, and red to manage traffic efficiently. KOP allows us to define objects and their interactions in a structured way, while markers serve as flags to indicate specific conditions or states. Understanding this setup is crucial for anyone looking to master traffic light control systems. And here's why that matters. Efficient traffic light programming can reduce congestion, improve safety, and even lower emissions. But there's more to uncover about how these systems work under the hood. Understanding KOP syntax and structure is crucial for efficient traffic light control. KOP, or Key-Oriented Programming, uses a key-value pair approach to define operations. Each key represents a specific function or parameter, while the value sets its configuration. For instance, the state key might define the current state of the traffic light, with values like red, yellow, or green. The timer key could set the duration each state remains active. Remember, the order of keys matters. KOP reads from top to bottom, executing each key value pair sequentially. Misplacing a key can lead to incorrect behavior or even system failure. To avoid this, always follow a consistent structure. Start with state definitions, followed by timers, and end with conditional checks. This organized approach ensures your traffic light system operates smoothly and reliably. Now, let's dive into the core mechanism of marker implementation in KOP for state management. Imagine each state in your traffic light system as a distinct point in a journey. Markers act as checkpoints, ensuring the system transitions smoothly from one state to another. The set_m block in KOP is your key tool here. It sets a specific marker, which is essentially a flag in the PLC memory, indicating the current state. For instance, setting marker M1 might signify third light state. To implement this, you'd use a set_m block with the parameter m set to 1. Remember, the value you assign to m directly corresponds to the state you're defining. This is crucial for maintaining the integrity of your state transitions. Now, let's dive into the full traffic light sequence using KOP. Imagine your traffic light system as a well-orchestrated symphony. Each note, or in our case, each state of the traffic light, must be precisely timed and executed. Start by defining your states, red, yellow, and green. Use KOP to create a state machine where each state transitions smoothly to the next. Set the duration for each state, red for 30 seconds, yellow for 5 seconds, and green for 20 seconds. Remember, the key to a flawless sequence is in the timing and the smooth transition between states. Ensure your KOP code handles edge cases, like rapid state changes due to external triggers. This meticulous approach guarantees a robust and reliable traffic light system. And here's why that matters. Debugging and optimization are crucial for efficient traffic light control. A common mistake in KOP programming is improper handling of timing parameters. Always ensure your cycle times are set correctly, otherwise, you'll face synchronization issues. Use the timeout parameter wisely. A value of 500 milliseconds often works best for urban settings. Another pitfall is neglecting error handling. Implement robust exception management to catch and log errors effectively. For optimization, consider using bitwise operations for state management. This reduces processing time significantly. Remember, the key to optimization is understanding the underlying hardware limitations and coding around them. This leads us to our final point. Subscribe to our channel for more in-depth, free technical education. This is the kind of knowledge others charge thousands for, but here, it's yours.